Okay, guys, so today we're looking at drawing our electric field lines. Okay, so there's just a few rules that we need to go over first before we start. Okay, so I'm going to start first with a positive charge. If I have a positive point charge, it's important to remember that our electric field lines always start at the charge and go to infinity. So they're going to start at the charge and they go out to infinity. So I'm just going to have the arrow at the end to represent going to infinity. Okay. On the other hand, if I have a negative charge, then my lines are going to start at infinity and they end at my charge. My arrows are getting a little big. Okay. Now, a couple other things to notice here. So, if you look at my positive charge on the left here, you notice I have 4 lines coming out from that charge. On my negative charge, I have 8 lines coming into that charge. Okay, the number of lines that we have on an electric, or the number of electric field lines we have, is directly proportional to the strength of that electric field. So here, my negative charge has twice as many lines as my positive charge, which means my negative charge here is twice as strong. The magnitude of that charge is twice as big as the magnitude of my positive charge. Okay. Other things to notice. If you look at both of these drawings, these lines never cross. Okay, and we are pretending these are like two completely different pictures. So we're ignoring the fact that those two lines would cross. Okay, but these lines over here on the right side of the screen never cross each other. The lines on the left side of the screen never cross each other. So when you're drawing electric field lines, those lines never cross. And the last thing I want you to notice, if I draw this purple circle right here, okay, look at how close the electric field lines are to each other, how much space is in between them, okay? If I draw a line out here around my red, now look at how much space are between those electric field lines. You can tell that there's a lot more space in this red section than there is in one of those purple sections. And what that means is that the farther apart those electric field lines are, the weaker that electric field strength is at that point. So you can see as you move out from the center of my charge, that electric field strength gets weaker, which should hopefully make some sense. Okay, so these are two individual point charges, right? On the left, we talked about positive. On the right, we talked about negative. Now we're going to work through some examples of what it looks like when we have two charges that are interacting with each other. And we're going to start off simple, and we're going to look at two charges that are equal in strength, and our first one, they're both negative. Okay, so I have my negative charges, and it's really tempting, right? Okay, so we have negative charges, they come in from infinity, they hit my charge. I'm going to do the same thing on this one, right? Okay, wrong. Because if you notice, these charges are crossing. That is not going to happen. So let's get rid of all that. Start back with my two negative charges. Okay, and it didn't start bad, right? If I have a line that's starting out here and coming in, that line is never going to cross with anything that, say, is over here and coming into my charge. And same with if I have here or there, or there, or there. They're never going to cross. Okay, and I can do the same thing with lines on this other negative charge. But if I have a line that's coming in this direction, that's going to start to cross. Couple problems. A, we said our electric field lines can never cross. B, if we have this negative charge, and say we have another negative charge here, they don't want to cross because like charges repel, right? Okay, and that repulsion between the two like charges that are coming towards each other is going to push them away from each other and cause them to bend. So this charge, as it hits something from over here, bends, and it's still going to end up going towards my charge, right? Same thing. So these charges bend because they don't like each other. They repel each other. They don't want to cross, they want to stay away from each other. Okay, so we're going to get that bending effect. Now if I look, I have 8 lines on my left charge, I have 8 lines on my right charge, so they are equal in magnitude, and I'm done with this one. Okay. Now what if we do the same thing, but this time we have positive point charges? So again, I'm going to draw my points, right? And if I start drawing lines, these are never going to cross. They're going out to infinity. They're never going to cross. Okay? Same with on this one. So that's pretty easy. But if I draw this point right here, that one would cross. And again, these positive charge on the left are going to repel it. So as it's going to get repelled and bend away. So you're going to see these ones bending, just like our negative ones. They're going to bend away. Make sure I get the right number in here. Okay, so now I should have 10 lines, if I counted right, on each one. They're not crossing. Those middle ones bend away from each other, but there's 10 lines on each, so they're the same size of charge. Okay. One more situation we could have. We again have 2 equal point charges, but this time one is negative and the other one is positive. So we have a positive charge, we have a negative charge. And to start with, this isn't going to change much, right? So we still have our positive charges. They start from our point and they're going out to infinity, right? Our negative charges are doing exactly the opposite. So they're starting at infinity. They're going to end at our charge. But now we have these ones that would cross, right? And in our last 2 examples, we said we had like charges, so they repelled each other and went off in opposite directions, right? Now we have opposite charges, and opposite charges attract. So these lines, if I have a line here, and I have a line here, they would actually bend toward each other. And if they both bend toward each other, they're going to end up connecting together. Okay, so that line would actually go there. And it's going away from my positive toward my negative. Same with the next 2. They would end up connecting. And it's going towards my negative. Okay, right? We have these 2 lines that are attracted to each other, always starting at the positive, always ending at the negative. Okay, And then again, if we go back and count here, I have 10 lines total that leave my positive charge. I have 10 lines total that end at my negative charge, so they are equal in magnitude, which all of our examples have been equal in magnitude. But what happens if they are not equal in magnitude? So this one we have a negative and a positive charge, just like the last example, but the positive charge is twice as strong as the negative. It really doesn't make your life much harder. So if I have my positive and I have my negative, okay, I'm actually going to start with my lines that are going to connect this time, just for fun. So again, they're going to go from the positive to the negative. And let's draw in a few more. Right, okay, maybe a couple more. I don't want to put in too many because, then your drawings get kind of crazy and it looks like lines are crossing. Okay, so right now I have 5 lines leaving my positive charge and I have 5 lines coming into my negative charge. But my positive charge is twice as strong as my negative. So I need twice as many lines leaving my positive that are coming into my negative. So I'm going to draw another 5 lines on my positive charge. And some of these are also going to start to bend toward that negative charge, right? Because they're still attracted to that charge. Okay. So now in the end, I have 10 lines that come out of my positive charge, but I only had 5 that connected to my negative. So you can see how these fields are connected. You can see that my positive charge is twice as big as my negative charge, and we can see how they interact.